So today our topic is direct memory access. So after knowing the theories, the huge amount of lectures, first of all we have to know that why we need this. We have various approaches in computer science. Why we need direct memory access? Why? What is this? What is the terminology? Basically, in real life application, suppose we are accessing or fetching some data from our computer system or mobile phones or laptop, etc. So for this case, suppose this is our input or output system. You can, I have given an example of taking some data from computer system. You may also think about that you are giving some data to computer system, anything. Okay, so it requires the CPU, then the CPU requires the main memory. So it takes 2 cycles, extra time, but we have not that amount of time. In our computer science engineering, our motto is less time. Okay, so how the 2 cycle can be reduced if we can direct access in this way. Got my point? In previous case, what is happening? This is happening, but now we are trying to happen in this way. Directly input or output system will communicate with main memory. This is the major concept of direct memory access. No, don't need a huge amount of lectures, nothing. Just need only the concept. Now, I am going to the depth. There are total 4 parts. 4. One is the mastermind of everything. That is central processing unit or CPU. Process name is DMA, direct memory access. To do this, we need a controller. What is the name of the controller? Direct memory access controller, shortly on DMAC. This is nothing but DMAC. Why we need this? To control direct memory access. What is direct memory access? I've justified that. Fine. After that, what do we need? We need a main memory. Why we need main memory? Because everything is done on main memory. So we need a main memory. This is memory. Say I told that we need 4 things, but there is only 3 things. The one left thing is, what is this? This is disk controller. I will later say why it is needed. Okay, so I am going a real life approach. I am giving a pen drive in my computer to store some data or song, you may say songs, to main memory. Okay, so I am inserting the pen drive to central processing, to the cabinet box, not CPU box, to the cabinet box. Suppose this is my external drive. Okay. Oh, I missed something, that each and every unit is connected by bus. Yeah. Why we need bus is the question. To communicate with each other, right? CPU wants to communicate with this controller. Why? I am coming that point. CPU wants to communicate with memory. Yeah, I am coming that point. So okay. So to communicate in computer, in our real life system we have phone, letters, etc., WhatsApp, etc., etc. But in computer system there is one and only one thing, that is bus. Fine, got it. So there is no problem. All problems are exhausted. Now I am coming to the external device. Suppose the external device is connected. CPU knows that there is an external device that is connected in my system. Therefore, in my computer there is a symbol for my pen drive system. Suppose my pen drive name is x/my. In my computer system, one file can be arise. Okay. So now CPU will say, or CPU will notify the disk controller to check whether any external devices is connected or not. If it is connected, then yeah, we are going to DMA. But if it is not connected, then no problem. Fine. So CPU will notify the disk controller to check whether any external devices is connected or not. Yeah, there is some external devices is connected. So CPU will say the disk controller to read the data. Let's read the data. What is written in the external device? Otherwise, how we can do anything of that with the data? Okay. So after reading the data, we need something to store. If we store directly main memory, it is not possible for us, or it is not possible for disk controller. Fine. So we have to store the data for some times. That's why we need a buffer. Because we know that it is the small time storage unit, buffer. The external devices, the data from the external devices is stored into buffer. CPU and disk controller communication ends. Now DMAC or new guest will start his activation with its activity. How? We know that everything on the computer system is created by central processing unit, as it is the brain of the computer. So it will say or give some instructions to DMAC that a data is came into buffer. You have to do something. Fine. Now, what is the internal structure of DMAC? The internal structure looks like in this way. DMAC. There are many type of registers, but we now consider only 3 type of registers. Only 3. This is a register which name is control signal. Why? I will come. This is a register which is basically for counting purpose. Which type of things counting? Why counting? I will come. This is a register for address. DMAC is exhausted. Now I am making 3 blocks. I have written the names here. Now DMAC will say the disk controller, if you get some data, then take it to the main memory. Okay, from buffer. Now, why we need buffer? DMAC can only take actions into the buffer. That means that DMAC can do anything only and if only the memory unit is buffer. Okay, DMAC will say the disk controller that if you take some data into the buffer, okay, throw it to the main memory. Fine. So the DMAC will say some instructions or instructions. The disk controller will throw the data which is stored into the buffer into the main memory. Fine. Our main achievement is completed. Okay. Now we can say that completed. But how computer will know? Computer needs some instructions. Fine. That's why the buffer will give a acknowledgement. What is this? Acknowledgement. That I completed my thing. Okay. Suppose I have suppose there are a lot of data. We have considered a small amount of data. As because buffer is small storage unit, we have a large amount of huge data. Let's say 4 GB data. So only a small buffer can't take 4 GB data. Okay. So the DMAC must know that how the process is going. It means that suppose there is 4 GB of data, and first time the buffer only throw 2 GB of data. So we have 2 GB more data. We have to process the thing again. For this, what we will need? You can smell a type of condition. Yeah, that's it. There is a thing which is known as counting. It counts. how the process will going on, how the process will be go on. In this various methods are counted in this part, that is counting. It is just byte counting. Okay. After completing the disk controller will send an acknowledgement to the DMA that I have performed. Disk controller will say I have performed my task. Now the counting register, it will decrease. That means that byte counter will decreased. Okay. Now if our all data is transferred, we have to check it. For this we have a checking condition that if byte count equal to 0, if it is satisfied, that our work is done. But if it is not equals to 0, then there is a problem. We have to do the thing again and again. Okay. So we have to do the thing again. What we have done? CPU will say the disk controller that's look and read the data from the external device. It will read the data and took it to the buffer. Then DMSU will tell that disk controller, okay, your data throw to the main memory. After showing that, it will send an acknowledgement to DMSU, yeah, I have completed. After that, the counting will decrease, again check, and after sometimes, as it is decrementing, after sometimes this condition will satisfy that B byte counter is equals to 0. That means that the thing which we have to copy from our external device to memory is done. We have told done. How the computer will know? The computer will know by an interpreted signal which will be produced in DMAC, Direct Memory Access Controller, and which will be transferred to Central Processing Unit, the main brain of the computer and the main culprit, whatever you say, of the computer. Fine, it will be a interpreted signal that, yeah, I've done everything. Fine. So it is a bit by bit explanation of direct memory access. Thank you.